This video will be discussing May-June 2025 paper 6.3, which is the Probability and Statistics 2 paper. Question number 1. We are given the information where the customer arrived independently and randomly at a constant average 23.4 per hour. Okay, so actually the keyword per hour give you a hint that it belongs to Poisson distribution, because for Poisson distribution, the lambda or the mean, okay, we will say the mean or maybe the average value will be given in a certain interval. So per hour is basically an interval, right? And you should know that the 23.4 is a lambda. So we know that it is Poisson distributed with the mean lambda. Okay, to calculate the probability for x equals to r, the general formula will be E negative lambda power r divided by r factorial. And then there's a shortcut formula. If let's say they're asking for x smaller equals to r, and the general formula can be E negative lambda. X equals to 0, it is always a 1. X equals to 1, it is always a lambda, followed by lambda square over 2 factorial, lambda 3 over 3 factorial, until lambda power r over r factorial. So it depends on what's the value of the r that you have. Okay? Yeah, I think these are the two general formula we are using very frequently in the Poisson distribution. Okay? Yeah. Then let's have a look for this question here. They want us to find the probability that in the 1 minute period, at least 2 customers arrive. For this question, we are given the lambda, which is for 1 hour. But they want us to calculate the probability for 1 minute. Therefore, before we try to get the probability, we need to change the lambda first. From 24, from per hour one, change it become the 1 minute period. 23.4 is for 60 minutes, right? To make it become the lambda for 1 minute, you have to divide it by 60 minutes. And what is the lambda for 1 minute here? It will be equals to 0.39. Then now only we start the calculation for the probability x greater equals to 2. And these 2 means that start from 2 and equals to 2, then continue with 3, 4, 5, 6, 7, 8 until infinity. For Poisson distribution, the x can be up to infinity. So quite impossible for us to calculate 1 by 1 until infinity, right? Therefore, we usually take 1 minus. So I'm taking 1 minus x smaller than 2. That means I need the calculation from 2, x equals to 2, 3, 4, and so on. And I don't want x equals to 0, x equals to 1. Alright, so I have to take 1 minus x equals to 0 and the 1. Then I take 1 minus e negative lambda. The lambda is 0.39 here. When x equals to 0, the term is always a 1. When x equals to 1, the term is always the lambda, which is 0.39. And I have to stop here because I'm interested only for x smaller than 2 when I want to take 1 minus. Okay, so this x equals to 0, x equals to 1. The 2 is not included in the minus part here. Okay, then again, just try to press calculator and get the answer. Make it correct to 3 significant figure. By right, you'll be having 0.589. Alright, then let's go to part B. For part B, the random variable x denotes the number of customers who arrive randomly in chosen 1 hour period. So highlight the keyword now. The interval that we are interested now is 1 hour. Use a suitable approximating distribution. Highlight the keyword approximating. From here, they already tell you very clearly that you are going to change the Poisson, become something else, right? And in our syllabus, Poisson can be changed into a normal distribution if you're having the condition where the lambda is more than 15. Okay, you can change become normal distribution. Poisson is a discrete random variable. Normal is a continuous random variable. Therefore, you are allowed to you have to apply some adjustment before you calculate the probability, and we call this adjustment as continuity correction. And usually the continuity correction will be plus minus 0.5. It depends on the question and the sign of the question. Okay. Right, then let us start the calculation part, yeah? We are interested for the interval for 1 hour, right? Therefore, we have to use the lambda or the mean for 1 hour, which is 23.4. Very obvious, it is already more than 15. Therefore, we have to change it become normal distribution. Okay, and what is the probability that we want to find? So we are going to continue in part number 2. Okay, so this is part 1, because part 1 is just ask us to state the suitable approximating distribution. So the suitable distribution is n, the normal distribution, and mean lambda are the same, which is 23.4. After that, in part number 2, they want us to calculate the probability. Use your approximating distribution to find this probability here. Okay, so like what I told you just now, x between 20 to 30 belongs to Poisson distribution. When you want to change become normal, you have to do some small adjustment, which is the continuity correction. What is the value for the x after the continuity correction? Alright, so you can try to imagine that we're having some vertical line graph like this. Then for all the vertical line here, we are having some values. Okay, 20, 21, 22, 23. Then maybe I put dot, 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 dot. Then I have 28, 29, 30, then 31. Okay, there are many more. For this question, they are saying that x is between 20 to 30, from 20 to 30. But if you have a look in detail, the 20 and 30 both has no equal sign. That means when you calculate the probability using Poisson, x should be starting from 21 and x should be ending at 29 because 20 and 30 are not included, right? Therefore, you try to imagine if you want to use Poisson distribution to calculate the probability, you have to start with x equals to 21 plus x equals to 22 and so on until x equals to 29. Okay, so the highlighted part is the area or the probability that I want to find originally. And then when you want to apply any adjustment, you have to make sure that the continuity correction line cover the area that you are interested to find. So this one, okay, so you try to read the value from here, it is actually 20.5, and if you try to read the value from here, it will be 29.5. Therefore, the continuity correction value will be 20.5 and also 29.5. Okay, yeah, so this is the step for continuity correction. After you apply continuity correction, you can start to standardize it because it is now the normal distribution. How can you standardize it? Okay, so you are taking 20.5, the value of the x, minus the mean. So what's the mean that you get just now? 23.4 divided by standard deviation. So the standard deviation will be square root 23.4. Same thing happened here for the upper limit here, 29.5 minus the mean divided by standard deviation. Okay, then try and see what's the value that you get. Yeah, when you press calculator, by right you get a long value. Please make sure that you keep it into 3 decimal places for the value of the z. Okay, and after that, how can I get the probability for this part? There are many ways for you to find out the answer. Okay, I just want to show you usually what I do for the area here. I know that I want to find the area between negative 0.6 until 1.261. And this is the area that I want to find. The shaded area is the area that I want to find, right? And now, I usually write it in this way. I try to figure out this area first from the table. And when I want to write out this purple color area, it can be written as z smaller than 1.261. Okay, after that, I want to minus the green color area. So you can see that purple color minus the green color, then you get the shaded area that we want. How to write the green color area? So the green color area symbol will be z smaller than negative 0.6. Okay, and now only I start to find out the value from the table. Z smaller than 1.261. So let's continue further. 1.261. 1.2 is here, then 6 is this one, then 1 means this. What you need to do is you have to take 8962 plus 2. at the last digit, then you get 8964. Okay, so I'm having 0.8964 here. I put it as purple color here. 0.8964. Then minus, for the green color part, I know that this area equals to z greater than 0.60. So I have to take 1 minus, find out the area for 0.6. Where is it? It is basically this one, 7257. So 1 minus 0.7257. Okay, then just try to use calculator and help you a little bit for the calculation. You will be having 0.6221 if you didn't do any careless mistake. And then after that, we usually will correct it to 3 significant figure. So it will be equals to 0.622. Correct to 3 significant figure. Alright, so this is how we solve question. Question number 2. The length of pencil is made by at the factory are normally distributed. Highlight the keyword normally distributed. The standard deviation of the length is sigma, and the mean is to be 10. Okay, the inspector thinks that the mean is actually greater than 10. Highlight the keyword greater than 10. Very likely this will be the keyword for you to set up alternative hypothesis. Yeah, he takes a random sample of 50 pencils produced at the factory and also find that the mean of the 50 length is 10.03. This 10.03 basically is referring to the 50 pencil, right? Therefore, this 10.03 basically is the sample mean. All right, and you should know that the 10 here refer to the mean of the pencil produced by the factory, which is a very large value. I mean, there's a lot of pencil. Therefore, the 10 belongs to population mean. Okay, he then carries out a hypothesis test. He finds that the value of the test statistic is this one. Correct to 3 decimal places. Calculate the value of alpha. Right, they already give you the keyword. Test statistic is 1.995. When you want to carry out a test for a population mean, we are using the sample, right? We're having a sample, which is normally distributed one. Okay, what is the formula for the test statistic? The test statistic formula, that is basically getting from sample mean minus the population mean divided by standard deviation over square root n. And since we already know that test statistic is 1.995, right? Then we try to plug in all the value that we get just now in the question. Sample mean is 10.03. Population mean is 10. Sigma, you don't know what is it, but you know that the sample size is 50. So you have square root 50 here. Then try to slowly move all the number to one side. Keep the sigma on the left. By right, you will get a long value here. And of course, for the answer of the sigma, we can correct it to 3 significant figure, where it should be equals to 0.106. Right? Yeah, so this is what you have for part 1. Then let's continue to part number 2. Carry out the hypothesis test at 2.5% significance level. Okay, so let's try to set up the question here. First step, try to write out the null and alternative hypothesis. We are having mu equals to 10 cm. Do you still remember we highlighted the keyword just now, greater than? So greater than basically is a keyword to help us to set up alternative hypothesis. Therefore, our mu will be greater than 10 cm. Okay, so that's my first step. Second step, we need to know, okay, what is the critical value. Usually for me, I will draw a normal graph because this is normally distributed. And I know that for alternative greater than 10, the rejection region on the right, then the area of the rejection region will be your significance level, which is 2.5%. So it will be 0.025. So this big color area, right, the big white area here will be 0.975. I want to know what is basically the critical value. Critical value is basically the border value that separate the rejection region and also acceptance region, right? Then let us have a look for the critical value. You need to find out the value in the reverse way from normal distribution table, but in the normal distribution table, they don't give us the area 0.025 because it is too small. So we have to look for the complement area, which is 0.975. Okay, then you go to the table part, scroll down to the bottom, because we have a shortcut table here. Looking for the area 0.975, and what is the value of the Z they give us? They give us 1.96, which means that this critical value will be equals to 1.96. And just now, we have been given the value of the test statistic, right? So you don't need to purposely go and calculate it anymore. The value of the test statistic is equals to 1.995. And I want to put it inside the diagram. Where is the 1.995 basically? So 1.995 will be here after the 1.96. And very obvious, you can see that 1.995 falls under the rejection region. Okay? But usually when we carry out the test, we still need to write out a comparison statement. So I can write out in this way. The value of test statistic (1.995) is greater than the critical value 1.96. But if you have a look from the diagram part, you know that it falls under the rejection region. Therefore, you should make a conclusion where you reject the null hypothesis. Then make the statement that is related to the question. So reject the null hypothesis means that there's enough sufficient, right? There's sufficient evidence to show that the mean length, or to show that the length they are talking about the length of the pencil, right? Just double confirm again, yeah. They're talking about the length of the pencil. So the length of the pencils is greater than 10 cm. Okay, yeah. So this is how we carry out the test. Then let's look for part number B. They ask you to explain whether it was necessary to use the central limit theorem in carrying out the test. When we want to decide whether is central limit theorem is used or not, basically just we just focus on one part, which is we just need to make sure and we just need to check whether the population is normally distributed or not. Okay, so from this question, you can see that they already tell you from the beginning of the question, saying that this population are normally distributed. When the population are normally distributed, then we didn't use the central limit theorem. So the answer is no, because we already know that population is normally distributed. Population is normally distributed. Therefore, since the population is already normally distributed, right? Automatically, we know that the sample mean will be also normally distributed. If the population is not known, whether is it normal or not, then we have to use the central limit theorem that stated that the sampling distribution is normally distributed. Okay, so for this case, we are not using the central limit theorem because we know that population is normal. Therefore, automatically the sample will be normal as well. All right, this is how we solve question number. Question number 3. There's a machine dispenses coffee into cups. The volume V of coffee in a cup was measured for a random sample of 150 cups. The result for these 150 cups are summarized as follows. We are having the summation of the V and also the summation of V squared. Calculate the unbiased estimate for the population mean and also the population variance. Highlight the keyword unbiased estimates. To estimate the population mean and also the population variance, the formula being used is something like this. Okay, to have the mean, the formula is the same like what we have previously, summation of x or summation of v divided by the n. But if you're having the variance, the unbiased estimated variance, Then basically there are a few formulas that you can use. I just show you one commonly used one. We'll be having 1 over n minus 1 summation of x squared minus summation of x squared then divided by the n. This formula is provided in the formula booklet, so if you can't remember, you can of course go and refer it from the MF 19 formula, right? Okay, then we can start the calculation here. To get the mean, just apply the formula. I'm having summation of V 46350 divided by the sample size, which is 150. And you'll get 309. Then let's go and get the mean, the variance. Formula for the variance is 1 over n minus 1. So 1 over n minus 1 will be 149. Summation of v squared, 144,10800, minus the summation of v, then you square it, 46350, you square, divided by the n, which is 150. Okay, then after that, you try to press calculator and get the answer lah. Then you will get the long answer here, 594.966443. Then of course I will correct it to 3 significant figure. It will become 595. Yeah, so this is how we get the estimated unbiased estimated mean and also the variance for the population. Then let's continue to the second part. Calculate a 95% confidence interval for the mu. Okay, then what's the general formula for the confidence interval for the mu? It is basically like this, x minus z, sample mean minus the z, then multiply with sigma over square root n. Same thing happen here. For the upper limit will be sample mean plus z multiply with the sigma over square root n. Okay, then we just need to plug in all the value correctly lah. Okay, so let's start the calculation. 95% confidence interval for mu. What's the sample mean? So sample mean is actually same as the population mean. That we get is 309. So you can have 309 here. Minus the z. Okay, so what is the value of the z and how can we get it? For the confidence interval, the z is having something like this. This is negative z, this is positive z. And then they say 95%, right? The 95% basically meant for the area in the center, 95. So this is 0.025. This is also 0.025. So that when you add all the three areas together, it is equals to the 1. And you can see from here that z is basically the value of the z that cover the 0.975 area of the graph. Because you can see that 0.95 plus 0.025, right? So total is 0.975. To get the value of the z, kindly looking for the 0.975 in the shortcut table, and you get the value of z 1.96. That means in this case, our z here will be equals to 1.96. Then the negative z definitely will be negative 1.96, right? Okay, so 309 minus 1.96 sigma. So sigma, I get the value from part 1 just now. I already get the population variance from part 1, which is this value. Okay, substitute inside, but I want the sigma, therefore I have to put the variance under the square root. When I write it out, I write out the short answer 595, but when I press the calculator, I will press the long value because this is already the simplified answer, right? When you do any calculation for the next part, you have to use back the original value. For me, I write out short, but when I press calculator, I press the long value, yeah? So please take note on this. Okay, then what is the sample size? Sample size is 150. Okay, then the same thing happen for the upper limit. You just put in all the value correctly. Okay, then use calculator to help you, of course. Then you will get the long value as well. Right, this is what I get for the long value here. Okay, then after that, I will correct it to 3 significant figure, where the answer will become 305 and also 313, correct to 3 significant figure. Alright, this is what I have for part 2. Then let's continue to next part. Now we are having another random sample of n cups of the coffee is taken where n is between 100 and 120. Now the sample size becomes smaller. Just now it's 150, right? N is the sample size. So just now it's 150. Now we are having n between 100 and 120. Then we also calculate another 95% confidence interval by using this sample. You may assume that for large sample, the unbiased estimated for population variance is still same. Very similar, I assume that they are the same. Without the calculation, state whether this confidence interval will be wider or narrower than the confidence interval that you found in part A2. Give the reason of your answer. Okay, so for part A2, the general formula that we have here for a 95% confidence interval is sample mean minus the Z, which is 1.96. Then we are having sigma over square root n. And the square root n is square root 150. Okay, then x plus z sigma over square root 150. Okay, then for part B, what's the formula of the confidence interval that we have? It will be mean minus z sigma over square root n. Okay, you try to compare these two confidence intervals. Basically, all the value are the same. Sample mean, z, sigma are all the same. The only difference in the number is the n. Okay, so for part A2, we are having square root 150 here. But for part B, we are having square root n. And we know that the square root n value, the n value here is between 100 to 120. Okay, we just need to do a little bit of analysis by using some common sense in maths. Okay, when I'm having sigma divided by a larger value, so sigma over square root 150 is smaller, right? Okay, if you compare it with sigma divided by square root n, where the n can be 100 and 120, 100 to 120 is smaller than 150. When we take sigma divided by a smaller value, okay, this one is larger than the value of sigma over square root 150, right? Okay, then what will happen if, let's say, sigma over square root n is larger? So when you take x minus a larger value and x plus another larger value, you can see that the confidence interval become bigger, which is wider. We'll call it as wider. All right? Yeah, so you can just try to explain in a way like this. Since sigma over square root n is larger than sigma over square root 150 from part A2. Therefore, the confidence interval in part B is wider compared with the confidence interval from part A2. So this part B1, the confidence interval will be wider because of when you take sigma divided by a smaller n, basically you will get a larger value than this one. Okay, therefore the interval is a wider interval. All right, so this is how we solve question number. Okay, question number 4. Emma needs to choose one person at random from 3, B, Q, and R. Okay, she plans to throw 2 fair coins and note the number n of heads, number of heads. If n is 0, she will choose P. N is 1, she will choose Q. n is 2, she will choose the R. By considering the probabilities, show that the choice made by this method is not random. Okay, so they ask us to talk about the probability, right? And they are interested to decide by using the number of heads. So let's consider the probability of the head first. If let's say there are 0 head when you're throwing 2 coins, what does it mean? It means that the first coin you get is a tail, the second coin you get is also a tail. So the probability is 1/4. Okay, and when you are having 1 head, what does it mean? It means that you are getting head tail. You may also get tail head. Both result give you the result of 1 head when you throw the result here. Okay, you throw the coin here, and basically you will get half. Then if you want to try to get 2 heads, what is the probability for 2 heads? This one shows that both are heads, so half multiply with the half, and this is the only result, and we are having 1/4. From here you can observe very clearly that the probability are not the same, right? Therefore it is not a good method right, to select the person. Okay, so the probability, so we can just tell them that the probability are not equal. Are not equal. Therefore, the choice made by this method is not random. Okay, yeah. So if you want to make sure that the choice that made by using the method is random, that means you have to make sure that every single person is having the equal probability to be selected or equal chance to be selected. So for this method, basically you can see very clearly that, oh, the probability are not the same, right? So that means this person you will be having when 1 head 1, okay, that means Q will be having the higher percentage or higher chance to be selected. So it is not a fair or a random sample that we form or that we choose. Okay, right, then let's have a look for part B. Now they say that Emma has to choose 2 people. I want to choose 2 people now at random from 3. Describe how Emma could use a single throw, highlight the keyword single throw, for a fair 6-sided dice to make this random choice. Okay, there are a few important phrases that you need to know here. The first thing is, now she wants to choose 2 people, and she only can use a single throw to choose the 2 people. So how can we make this happen? All right, using a fair 6-sided dice. We are having 3 people, right, in general. So we can actually assign each people with 2 numbers. Assign each people with 2 different numbers from the dice. So why we need to make this is because of to make sure that they are having equal chance to be selected. And you need to maybe emphasize that there's no repetition number can be used. Right? No repetition. So as example, okay, so first person or first people will assign the score of 0 and 1. Oh, sorry, 1 and 2, because dice is 1, 2, 3, 4, 5, 6, right? Then the second person, you can assign them with 3 and 4. Okay, then the third person is having the score of maybe 5 or 6. All right, then from here, you know that all the probability is equals to 2/6, which is 1/3. From here, you can see that each of the person is having the equal chance to be selected because all the probability are the same for them to be selected, which is 1/3. But now the problem is, I have only single throw. I have only 1 throw to choose 2 people. So how can I make this happen? Yeah, all right. Then what we can do now is throw the dice once. Okay, then get the person who will be eliminated. Okay, so that means instead of using a one throw to choose two people, right, what I do is that I throw the dice once, and the number that I get is the person that I want to eliminate him or she from the group. Then the remaining people will be the two people that we want to select. Understand what I say or not? Right? Because with single throw, we cannot choose two people at once, right? So what I can do is like by using this single throw of a dice, I actually exclude that particular person or people from being chosen. So throw the dice once, get the person who will be eliminated. So that means this person, then the remaining two person will be selected. Okay. Yeah, so this is basically what we can do lah, to select two people using a single throw of the dice. Right, this is how we solve question number 5. In a country, the mass in kilogram of men have this distribution. It is normally distributed with the mean and variance here. There's a certain footbridge in the country can take a maximum safe load of 1,500 kilogram. That means any weight more than this weight, okay, this 1,500 kilogram, maybe will make the footbridge unsafe. All right. When n men stand on the bridge, the probability that the bridge is unsafe is less than 0.01. Okay, stating necessary assumption, find the maximum value of the n. All right, then before we start the calculation, let us try to state a necessary assumption first. Okay, we are having the man in this country, right? So to select the man to be on the footbridge, we have to make sure that the men are selected randomly. So you can say that the men, okay, on the footbridge are a random sample or are selected randomly, are a random sample from the country. So from Iberia or Iberia, okay? Then after that, let us start the calculation. We are having n mens, right? Maybe I can define the T as the total weight of n mens. Okay, since the weight of the man is normally distributed, therefore the linear combination for n men, that means we are adding all the weight for the man, right? For n times for the n man. Okay, it is a linear combination. Therefore, the T, the total, is also normally distributed. What is the new mean here? So you are taking 70.3 plus 70.3 plus 70.3 for n times. Therefore, you are having 70.3n. For the variance, is also the same. You are having 5.9 square plus 5.9 square plus 5.9 square for n times. Therefore, you are having 5.9 square n for the variance. Okay, and after that we get the total, the mean, and also the variance for the total weight. Then let us start using the information here to get the value of the n. What's the useful information here? Probability that the bridge is unsafe. When will the bridge be unsafe? If the total weight of the man greater than 1,500, then the bridge will be unsafe, right? Okay, then it is less than 0.1, so the probability is less than 0.01. Okay, then now I have to use this information and try to get the value of the n, find the maximum value of n. Okay, so let's start. To find out the probability for the t here, I have to standardize it become z because it is already a normal distribution. Okay, then I will be taking the value of the t, 1500, standardize it, so minus the mean divided by standard deviation. So square root of 5.9 square will give you 5.9. Then the square root n will be square root n. Okay, so this is a standard deviation, then smaller than 0.01. Okay, so let's assume that this is equal first, equals to 0.01. How will the graph look like if I want to visualize it using a diagram? So what they said here is z greater than a number small is equals to 0.01. We assume that it is equals to first, yeah. So that means I'm having a value with an area on the right hand side, and this area is 0.01. So what happened to this white color area here? It will be 0.99. Okay, yeah. Then after that, what is the value here to make a area greater than this value of z is equals to 0.01. So of course I have to use the table in a reverse way to find out the value of the z. Okay, I cannot look for 0.01, so I have to look for 0.99. Again, go to the table, scroll down to the shortcut table here. Where is the 0.99? You can see this is part of the value, and the value of z is 2.326. Okay, then I know that this is 2.326. So when z is greater than 3.326, the area is 0.01, or the probability is 0.01. Okay, after you know the value of the z, then let's have a look for this question, yeah? What is the value of the z in my calculation? So this is the value of z, right? If I want to have the area smaller than 0.01, that means this value must be more than 2.326, right? Because if this value of the z that we have more than 2.326, then only it will form a smaller area that is smaller than 0.01. Understand what I said or not? Therefore, this value of the z should be more than 2.326, so that the area that I get from this equation or inequality will be less than 0.01. Okay, when the value is larger, the area that formed will be smaller. Okay, when the value of the z is equals to 2.326, then the area is exactly 0.01. But now we're looking for smaller than 0.01. Therefore, the value should be more than 2.326. Okay, yeah. Then from here, I rephrase everything slowly, and I want to get the quadratic equation. I will be having 7.3n, then plus 2.326 multiplied with 5.9. You'll get 13.7234 square root n, then minus 1500, and it is smaller than 0. From here, you can see that you are getting a quadratic form inequality, right? And how to solve the quadratic form inequality, you might need to draw the number line or whatsoever lah. But before that, I have to find out the value of the square root n first. So what is the value of the square root n? You basically have to use the quadratic formula, negative b plus minus b squared minus 4ac. I write it out short, but when I press the calculator, I press long. So b squared minus 4ac divided by 2a. Okay, then the two value of the n that I get is this one. I will get negative 4.72, correct to three significant figure. Another value will be n, square root n is equals to 4 point something, 4.52. Okay, then I try to use this critical value to find out the answer for inequality. But of course, if you didn't show this, also never mind, because usually when you want to solve inequality, you can directly get the answer. Okay, negative 4.72 then I'm having 4.52. Okay, assume that both are going to the right. I'm looking for the negative, right? This is plus, this is minus, this is plus. So the answer by right for me to have it for square root n is this one. Therefore, I'm having negative 4.72, then square root n, then 4.52. Okay, but we have to ignore the negative part here because square root n cannot be getting a negative value. Alright, so we maybe put it as 0 lah. Okay, n is between 0 until 4.52. But I'm interested to get the value of the n, not the square root n. Therefore, I square everything. Therefore, the n should be having 20 point something, 20.4545 45425 So for information, right, when I write out the answer short, but when I press the calculator, I still keep the original long value. Then if I keep and square it, I will get this one. Alright, then for our question here, you know that n means the number of men. It must be an integer. And they're also asking for the maximum value of n. The maximum value of the n. What is the maximum or largest integer for n smaller than 20.4? From here, you know that the largest integer will be 20. Okay, therefore, the maximum value of the n should be equals to 20. Okay, yeah, so this is how we solve question. Question number 6. We have a random variable x with this PDF. Okay, x is defined from 0 until b, and the function is ax, where a and b are constant. Show that a equals to 2 over b squared. Okay, we are going to use the idea where when we integrate a continuous random variable, right, the function, yeah, for all the x, the defined x, for the function, and it is always equals to 1. Okay, alright, then let's start here. Yeah, I have to integrate from 0 until b for the function ax. And I know that if I integrate this whole thing, right, I will get the area under the graph equals to 1. Okay, a is a constant, therefore I just try to copy it. Then integrate x, I will be having x squared divided by 2. Then I have to put in the limit b and also 0. Okay, so from here I'm having a over 2. Then substitute b inside, I'm having b squared minus 0 squared. And it is equals to 1. And from here, we move all the value to the other side. And very easily, we'll get a equals to 2 over b squared. Okay, this is what we have for 6a. Then let's continue to 6b. They want us to show that the probability of e smaller than expected value of x is equals to 4 over 9. Okay, let's recall a bit about the expected value of the x first. In a continuous random variable, to get the ex, we have to integrate all the value of the x and multiply the x with the function fx first before you want to start the integration. Therefore, in this part, the first step is we need to know what is the value for ex first. Okay, so to get the value for ex, I need to integrate from 0 until b. Multiply the x with the function. So the function, I will substitute a by using the result in part 1, part a. So I'm having 2 over b squared. This is the a, right? Then multiply with the x. Okay, 2 over b squared to me is a constant. I take it out first before the integration. Only I start the integration for x multiplied with x, which is x squared. Integrate x squared, you'll be having x power 3 divided by the new power. And you want to submit the value, substitute the value 0 and also b. Then again, I will take out all the constant first. I'm having 2 over 3b squared now outside. Then I'm having b cubed minus 0 cubed. Simplify the answer by right, I will be having 2 over 3b. This is the value of the expected, the mean, okay, or the expected value of the x. Then now, I have to start the probability. Okay, so to get the probability of x smaller than ex, that means you are looking for x smaller than 2b over 3. To look for the probability, you also need to apply the integration, start from the minimum value 0 until 2b over 3 for the function that we have. Again, I always prefer to take out all the constant first. Only I start the integration. So integrate x, you will be having x squared over 2. Put in a value 2b over 3 and also the 0. Again, I take out the constant first before substituting the limit. So 2b over 3, substitute into the x, you'll be having 2b over 3 square. Then minus 0 square. Okay, then after that, what do you get? If you put the square in the bracket, you'll be having 4b square over 9. Simplify them. This is how you get the answer that they want you to show, which is the probability of 4 over 9. Okay? Yeah, so this is how we solve question number 6. Right, the last question for this paper. In the past, 1/4 of job applicants at a certain firm has first-class degree. 1/4 give you the idea where you're having 25% or maybe 1 out of 4. Okay, so for me, I write it out as 25% or 0.25, the probability. A change is made in the job description and a director of the firm believes that on average, the proportion of job applicants with first-class degree has decreased. Highlight the keyword has decreased. When you want to apply or carry out the test, right, this will be the keyword to help you and set up the alternative hypothesis. Okay, in the month following the change, there were 35 job applicants. R of these had first-class degree. R means the observed value, and we need to maybe try to get the observed value later, but they didn't tell you what's the observed value here. They just put it as R. The firm carried out a hypothesis test at a 4% significance level to test the director's belief. Use a binomial distribution to find the largest value of R that would provide sufficient evidence that the director's belief is correct. Provide sufficient evidence that the director's belief is correct. Okay, maybe before that, if you're not so sure what are we going to find out, let us try to write out something that we know first. When we want to carry out the test, right, we must know what is the null and also alternative hypothesis. And they said 1/4 of the job applicant are first-class degree. So P is equals to 0.25. After that, there's a director, right? Director of the firm believe that on average, the proportion has decreased. So the director suspect that the rate has been decreased. Therefore, the P will be less than, decrease means smaller, right? So less than 0.25. And you need to know that basically this is the director's belief. Okay, so this is the director's belief. And if you try to read the question one more time, they said, find the largest value of R that would provide sufficient evidence that the director's belief is correct. What's the meaning for this sentence? Sufficient evidence to show that the director's belief is correct means that null hypothesis is correct, which means that you reject the the alternative hypothesis is correct because director's belief is alternative hypothesis, right? So when they say director's belief is correct, it also have a meaning where you are rejecting the null hypothesis, but you accept the alternative. So what are they asking for now? They're asking for the value of the R. What is the observed value so that we reject the null hypothesis? Okay, so that's the meaning. All right. Okay, then let's continue further. After we set up the null and alternative hypothesis, then we need to know what's the distribution to be used here. They already tell us very, very clearly. You have to use binomial distribution. So we're having binomial here. What's the total job applicants? We have 35 of them. And then what's the P probability in null hypothesis? It will be 0.25. Okay, then when we want to carry out the test, right, to know the rejection area or the value of R that we want to reject the null hypothesis, we have to carry out the calculation one by one. Okay, and then usually for this kind of question, for binomial, I will put a bar chart like this, but this is not a valid bar chart. Please don't show this in your exam. It is not the correct one. But it is just help me to visualize a little bit about the test. Okay, so let's say I'm having binomial distribution from 0 until 35, and then my rejection region will be on the left because smaller, therefore my rejection region will be on the left. This is my rejection region. And how big is this rejection region? They are talking about the 4%, yeah. So the area of the rejection region will be 0.04. Okay, and then to see what is the value of the R, they are asking for the largest value of the R to reject the null hypothesis. So you have to start the possible value first, yeah. And then usually 0 is definitely in the rejection region, right? Then what you want to do is that you can try from 1, 2, 3, and so on. Alright, so 0 is definitely inside. I don't want to waste my time to calculate it. Usually I will start from x smaller equals to 1. Okay, then using binomial, so you have to start from x equals to 0, which is nc0, p power 0, q power 35, or power n. Then next one is x equals to 1, so 35 is c1, 0.25 power 1, 0.75 power 34. Okay, so first of all, you try to get the value for this one first, and you realize that it is 0.000466, correct to 3 significant figure. And then when you try to compare this one with your area, it is 0.04, right? The significance level is 0.04. This value is still very much smaller than the 0.04. That means if you try to put in 1 inside your diagram here, the 1 should be somewhere here. So that the area for x smaller equals to 1, the purple color area is super small compared with the 0.04. So very obvious, 1 is under the rejection region. Okay, since I know that the x smaller equals to 1, this probability is very much smaller than 0.04, then I try to be more adventurous where I try to skip the 2. Maybe I try the next value will be 3. X smaller equals to 3, which means that you are taking the previous value at x equals to 2. And then also add x equals to 3. Then let's see what is the answer that we get here. And if you didn't do any careless mistake, by right, your answer correct to 3 significant figure should be 0.0136. Compare it with your significance level, it is still less than the significance level 0.04, right? Okay, so that means also if you want to have a look here, basically it means that your 3 is still inside the rejection region, so that the blue color area, which is x smaller equals to 3, still smaller than 0.04. Okay, then 0.01 and also the 0.04, they are not too far away from each other. Therefore, I dare not skip the value anymore. I will try out the next value, x equals to 4. And now I want to see whether the 4 is in the rejection region or in the acceptance region. So you take the previous value again, plus x equals to 4. So 35 C4, 0.25 power 4, 0.75 power 31. And from here, you get another value, 0.0409, which is already more than the significance level 0.04. Then, if I try to show it in the diagram, how will it be? So you can see that your 4 is already under the white color area because the black color area, x smaller equals to 4, that you get is already more than 0.04. Okay, so from here, this is what you can see. 0, 1, 2, 3 are all under the rejection region, but the 4 already falls under the acceptance region. Okay, then we revise the question one more time. What are they asking for? They're asking the largest value of R so that you can reject the null hypothesis. What's the largest value of R that is under the rejection region? So you can see that the 3 is the largest value of R that's under the rejection region. Therefore, you can just tell them that your R is equals to 3. Okay, it also means that x smaller equals to R is the rejection region, or x smaller equals to 3 is the rejection region. Okay, so in my question here, try to answer the question, the value of the R should be equals to the 3. Okay, yeah, so this is how we figure it out, right? Then from the marking scheme, you can see that basically what they do is that they directly start with x smaller equals to 3. But usually for me, I did not skip so many numbers, right? I will start from 1, then only I decide whether is it very far away from the significance level or not too far away. Then only I decide whether I want to skip the number or not. Okay, but of course, if you are confident, you can directly start with x smaller equals to 3 lah. Or maybe you can try an error first, then only you start straight away with x smaller than 3, followed by x smaller equals to 4, then your step will be shorter because you skip some number calculations at the beginning. Alright, yeah. And just to remind you all that this particular diagram cannot be shown in the exam because it is not the correct graph. But to me, it will be very helpful because it can help me to visualize what's the value of the x that is under the rejection region and which one is under the acceptance region. Okay, right. This is what we have for part A. Then let's continue to part B. Now they say that in another month, the director carries out a similar test at 4% also, the significance level using the 35 job applicants from that month. Explain the meaning of the type 1 error in this context and state the probability of the type 1 error. What is the definition for type 1 error? The definition of type 1 error is you reject the null hypothesis when the null hypothesis is true. But they want you to explain it in the context of the question. So reject null hypothesis, what does it mean? Say we actually reject null hypothesis means that we conclude that the director belief is correct, or maybe if you want it to be clear, you can say that we conclude that, or the director conclude that the application, the job applicants rate applicants with first class degree, the rate of job applicants with first class degree has decreased. Okay, we reject the null hypothesis. So reject null hypothesis means that we conclude that the rate is decreased. Okay, but null hypothesis is true, although it is not. Okay, then after that, what is the type 1 error? So the type 1 error, according to the definition here, is the probability of reject the null hypothesis when null hypothesis is true. So for the calculation just now, right, x smaller equals to 1, small x equals to 3, and also the 4, which one give you the result of reject the null hypothesis? Here, still reject the null hypothesis, right? But this one, we already accept the null hypothesis. So the largest value for the probability will be 0.016. So this will be our type 1 error. Okay, then type 1 error is equal to 0.0136. Correct to 3 significant figure. So maybe you will ask why the type 1 error is equals to x smaller equals 3 that we calculate just now. Basically, from here, you know that your x smaller equals to 3 is the rejection region, right? Okay, so when you want to calculate the type 1 error, you need to put in the rejection region, which is x smaller equals to 3. And this is exactly what it did already just now. Therefore, this is also directly can be written as the type 1 error. Okay, then the last part. Now, given that the proportion of job applicant with first class degree this year is actually 0.05, find the probability of type 2 error. Okay, how to calculate the type 2 error here? Again, let us write out the definition first. Type 2 error is you accept the null hypothesis when the null hypothesis is false. Okay, accept null hypothesis means that you need to put in the acceptance region. Just now you know that x smaller equals to 3 is the rejection region, right? in part 1. Okay, and now to put in the acceptance region, you know that it should be x greater than 3. Then given that null hypothesis is false, that means p cannot be 0.25 anymore. So what is the value that you should use? You have to use the probability given here, which is 0.05. In short, it also means that your binomial distribution now has a little bit of changes. Okay, we are still having 35 job applicants, and then the P now, the probability now is actually 0.05. Okay, to calculate the probability of x greater than 3 in a binomial distribution, you have to take 1 minus x equals to 0, x equals to 1, x equals to 2, and also x equals to 3. It is quite tedious, so let's try to write out one by one. For x equals to 0, it is this one. 35C0, 0.05 power 0, 0.95 power 35. This is x equals to 0. We also have to minus x equals to 1. Minus x equals to 2. Then also minus x equals to 3. Okay, so please press calculator very carefully. Get a long series of answer, the value. Okay, then of course we have to cut it short into 3 significant figure. Then by right, the answer that you get should be 0.0958 correct to 3 significant figure. Okay, so this is how we answer the question number 7. And this is the end of the video. Thank you very much for watching the video.